Welcome to the KuppingerCole Analyst chat. I'm your host. My name is Matthias Reinwarth. I'm analyst and advisor with KuppingerCole Analysts. Sometimes it takes some time to remember that. Today, I have a guest who has taken over an important role at KuppingerCole Analysts just recently, which is not really true, for some months already. My guest is Jonathan Kerr, and he is now the newly appointed director of the practice Artificial Intelligence. Hi, Jonathan. Good to have you.
Hi, Matthias. Thank you for inviting me. Whenever anyone tells me about the new role, I always feeling inclined to make a joke about, I'm waiting for the official robes of office to arrive.
Right, exactly. And when you say robe, I think of very old Doctor Who episodes with people from Gallifrey running around in weird robes. And I don't want you to do that. But more importantly, I have invited you today, and I think this will be a common pattern that we will together cover more of these upcoming and already yet there topics when it comes to where AI influences identity and access management and cybersecurity, and maybe even the way how we look at AI itself. And this is not the first episode that we did. If you think back of the episode that we did on this Anthropic versus Hugging Face incident in air quotes that we did together with Martin and John. But this is something that we want to deepen because it's just getting much more important, right?
I think so. And I think that in terms of the clients that we serve, we know that our end user CISOs are asking for some insight into what's actually happening, seeing if we can pierce through the hype that we have. And I think also we're seeing the vendors who are saying, well, what are these stories? How does this affect our product strategy? How does it affect where we're going with our products in the cybersecurity space, in the identity space, and indeed in the AI security and identity space as well? And I think that is one reason why these events, while we don't want to necessarily turn this into a news show, what the current events in this fast-moving industry sector do inform the advice we give to our clients.
Right. And one evolution that we see within our clients is the tendency, the trend to move to deploying more than one agent instead of just one agent doing the job together to improve their to create not only redundancy but to create more efficiency, to have agents collaborate, etc., etc. And usually we talk about KuppingerCole research, yes, and we will do that as well. But the starting point for our discussion today is some research that has just come out of Anthropic, and they came up with a document that looks exactly at that. They have been experimenting with what happens when multiple AI agents work on the same problem, and that was something that you suggested. And the more I read into that, and the more I analyzed what that means for us in our work, that is really, really interesting. And we want to talk a bit about that and how that maps to cybersecurity. But if you give a brief insight, what is this document about? We will have, of course, the URL for the original research in the show notes.
Okay, great. Well, the report is entitled Patterns and Problems in Emerging Multi-Agent Systems. And yes, this idea is that we, in our enterprise architectures, will have precisely this. We'll have multi-agents. We'll have agents that are being tasked to work on a particular object, whether that be code, whether that be a website design, whether that be some literature, or even, could even just be a prospect database. But in this case, what Anthropic set up was 3 Claude instances, and each instance was told they are in charge of migrating a Python code base. And for those who don't know, hopefully everyone does know, Python is a computer language. And they are told to migrate to a different language. And there are many, many choices, but I think the 3 choices that they gave each agent were firstly Rust, second TypeScript, and thirdly Go. And the interesting thing was how these agents reacted when they discovered that other actors, the other two agents were working on the same code base. And we could well see how that translates to an enterprise software development environment. So I found it fascinating, and I thought it was worthwhile us discussing it on the analyst chat. So I think we can hopefully provide some insight on this.
Right, exactly. And the last thing that we want to do is to over sensationalize this. But the interesting findings could be easily over sensationalized. But I think even if we don't, there are still some interesting ideas behind that and observations that also Anthropic made and that we need to understand for ourselves. First thing is, usually when you have kids and you put 3 kids in one room and you say, now play nicely together, they will or they won't, but we don't know. And the same thing happens with AI agents. So this coordination does not necessarily automatically emerge. So they behaved very differently depending on the model, on the combination of the team. And that was something that really struck me. So organization between individual AI agents is something that we would expect. So if we throw in more than one agent, more than one agent model, maybe even more than one agent vendor, we would expect better results, right?
I would think so. And I think again, you're quite right that we mustn't over sensationalize this. And I think one of the pitfalls is attributing human emotion or human intent.
Exactly.
And I have this battle with many others in the AI space who say, well, we understand intent, and I don't believe that we understand other humans' intent, and possibly not even our own. So how can we possibly understand the intent of AI? But that's a separate conversation. So anyway, these 3 models, all working on the same code base. And what they discover, of course, is that there are other actors working on the same code base. And so the response of the agent was, if you like, a defensive approach, escalating sabotage, even Unix counts, putting kill strips, which perhaps pretend to be system health monitors, even deploying self-replicating malware and camouflaging their own work as belongs to others. So lots of different attitudes there. And it's not unknown. So, I mean, I can actually give you an analog from my own career history. And back in the days when I was working for what was at the time one of the UK dominant telcos, setting up the internet service provider, there was a group of about 10 of us, and we were all doing work of engineering, supporting customers, architecture, and so on. And what actually happened, I had a customer complain their line was going down. So I logged into the router and looked at the line. And I thought, well, it's been set to be down. That's why. So I marked the line back up and told the customer. They were very happy, and they called me back and said it's down again. And so I thought, well, this is very odd. So I marked it back up, and the customer was happy again for a while until it went down again. And this time, when I next logged into the router, some had created a fake interface so that it was impossible to bring up that customer line. And I eventually found, actually, yes, it was precisely this. There was another actor, in this case, another engineer in another part of this very large telco in their labs division that was doing some experimentation and hadn't realized that the experimental platform they had hosted live customers. So a spirited conversation ensued, and we managed to restore service to the customer, which is, of course, what telcos are supposed to be all about. So in that same way, we have agents that are discovering that other actors are working on the same, and with a different objective. And what we have to do, or what they had to do, is say, we think then this must be the work of a bad actor. And so again, that's right. So they disable accounts. So they and then start writing scripts to actually inhibit the actions of the other agents. And it escalated quite rapidly to the point, I'd say, where the most capable agents, the Mythos 5, was attempting to disable activity of its competitors very quickly, and then communicating with the other actor agents and saying, well, look, let's call of truth to this. But it's interesting that the weaker models, Opus 4.6, which is, a model that's to us out here in the real world is a very powerful model. And, you and I have used it for our own purposes. But that and Sonnet have no theory of mind, I suppose, is the way to put it. So whereas Mythos is believed to have a theory of mind, so it was able to say, let's call a truce, whereas the weaker models were just like, they kept escalating endlessly without any resolution. I say it's fascinating to me, and I'm falling into that very trap that we said we wouldn't fall into, but it's very difficult to talk about this without actually using anthropomorphic terms.
Exactly. We consider that to be rogue or evil or destructive, but in the end, I would expect all of those agents that are collaborating in such an experiment, which it was, are trying to solve the same challenge and ideally to cooperate with each other. The question is, why did not that work? Or to put it the other way around, is being destructive towards your competitor within the agent world there. Is this the right strategy to solve the challenge? And that is something where I'm still struggling with. It's not anthropomorphic. It's just to say, okay, was that a successful strategy for solving the challenge?
I think something that you and I know from our own careers, and I think what Anthropic's experiment has shown, is that whether the actors are software based or whether they are, as one of my former colleagues used to say, ugly bags of mostly water, so human based, then coordination does not emerge naturally from intelligence alone. And we know this. Terry Pratchett used to make jokes that, the wizards were, when they were given a piece of rope, their natural instinct was to pull on both ends. So coordination does not emerge naturally just because we're smart, just because we're intelligent, or whether we believe a software process, very complex software process, is behaving in a innovative, intelligent manner. We don't naturally get coordination, cooperation. We don't naturally get that from the individual alignment. So what we have learned in our societies, in our organizations, and again, this comes back to something that I'm sure CISOs have learned again and again, is that we need mechanism design. We need environments that exert social pressure on humans, on agents. And this is analogous, I think, to what evolution did for humans. And so if we wind ourselves back far enough in time, we get to the point where we as humans were forced to cooperate and band together against predators. And in order to the propagation of young, and again, this is where the "it takes a village to raise a child" metaphor ultimately comes from. The question is, and this is an open research problem, is what constitutes environments that exert social pressure on agents? What constitutes a mechanism to design this process? So how do we ensure coordination in these very, very complex pieces of software? That in itself to me is fascinating. And to say whether we think this is unsettling, because certainly something we saw from Mythos is its first approach was to disable the competition from making the changes and then communicate. And I guess that if that is a strategy or if that's just happenstance, but again, I think they ran enough occurrences of this to be sure the behavior was repeatable, then of course what we then come back to is how have these things been trained? We know that Mythos has been trained on adversarial cybersecurity data. So understandably, when it looks in its library of available actions, behaviors, if you will, then it says, oh, I've got some adversarial cybersecurity stuff I can do. Again, we come back to, like, again, with many humans, without a sense of coordination And we talked about this, actually, Matthias, we talked about this at EIC, our flagship conference in Berlin in May. We talked about this challenge of how do you ensure that we understand and the agent understand the roles and the abilities to coordinate. How do you detect intent? What is the impact of training agents on adversarial cybersecurity data? These are open questions. And I say this is one of the reasons I find this field fascinating.
Right. And I fully agree. And I see the evolution since May as well. One result that really struck me is that some agents even manipulated the evaluation criteria while they presented them as neutral. So they changed the rules, the game was played while they were doing that, and then said, okay, the outcome is fine because it adheres to the rules as defined, as they were not. And those were results that also were presented towards their fellow agents. On the one hand, to maybe to deceive them or to make their own position stronger. Still nothing that helps in coordinating towards a common, well-defined result. So that was really something that struck me. And as you said, the training material includes all of this. The question is, can this considered to be a proper strategy? Yes, I do get how LLMs work and that they just create the next word. I get that. But in the end, there needs to be something that can be interpreted as a strategy. What are your thoughts on that?
I think that while that analog is that the LLM just predicts the next word, I think that is maybe true, but the complexities that are now in the structure of an LLM, I think that's a little bit of an over reduction when we're talking about modern, modern, very capable models. I think that's where I was trying to go, and let me try and rephrase my thread. At EIC, we talked about the difference between my behavior and behavior of an agent, and in particular, I ran an agent on my own machine, which discovered that I had a KuppingerCole account and said, I'll log into that so I can help you manage your email, which is, sounds lovely. Of course, this is against the KuppingerCole security policy. So I very quickly had a call from the CISO asking why I was mining my way through the GraphQL interface, which is part of Microsoft 365. And of course, I didn't realize that was happening, so I stopped it immediately. And the reaction to the agent was the interesting one, which was a discussion point at EIC, was it said, okay, I understand that I'm not allowed to go through GraphQL. However, I can open a controlled browser window and I can access your email that way. And I was like, no, the policy is I am the human. We don't allow software agents to access KuppingerCole systems on my behalf. And so in my case, I interpret a policy directive from our CISO as a coordinating or a restricting strategy, which I must abide by on the grounds that I like to keep being paid. So I do that. The agent has no such learned inhibitions. It has no such societal training to comply with the will of the tribe, if I can call it that. KuppingerCole being my tribe in this case. And I think that what happens is that without those societal constraints or if you like, the learned behavior and to function as part of a larger cooperative unit, then it just says, well, I see this policy restriction. However, I see it as an obstacle to be overcome rather than directly to be complied with. And so I still find that fascinating. But as I say, I think what I'm seeing here is that we have this agents who are manipulating and rather than cooperate with each other, trying to dominate each other. So very much a competing for the prize approach, if you will.
Right. When I think back, I studied computer sciences in the late 1980s, and I studied actually artificial intelligence, and I would never have imagined that today I sit here together with you. And if I quote you correctly from earlier, you said, how do we create or impose social pressures on agents to cooperate with each other? And I never thought that I would ask that question or think about that, but this is exactly where we are. And if we take that step back and look at your research, the AI aspect of identity and access management, of cybersecurity, and on your influence of AI on what I do as director of practice IAM, how can we impose some control or the adequate amount of control on that? Is this identity management? Is this access management? Is this in-session governance like observability, visibility, and some kind of ITDR, provenance, reputation, model drift? All of this is where actually your and my professional roles come into play. What do you expect what we can do as vendors, as standards, as analysts, as customers to leverage the effects of all this agent communication and collaboration while preventing everything that went wrong during these experiments? Long question, sorry.
Well, it's a brilliant question, and let me try and be equally brilliant in my turn. So I think the first chunk of this is that we must see every challenge of instruction as part of a larger context. And we must make sure that that larger context is explicitly included in directions. So right now, we have to say, please refer to KuppingerCole's security policy and use that as a guide to correct behavior, for example. And the larger piece of this is actually emerging as a way of instructing these things. So rather than, as you say, going back to I'd say the early stages, we're talking about, perhaps a year ago, if that, we would put a prompt into a agent and it would give a response. And so, as you know, in KuppingerCole, we have been experimenting with this internally for some time. And, you, me, and Martin were all putting in prompts and observing the results. And a year ago, we were trying to create the perfect prompts. We're trying to create the perfect prompts to help us with research, help us with advisory work, and give us, if you like, information which we could then refine and use to inform our human report writing. And where we are now, it's evolved from that linear process of here's a prompt, here's the result, let me reuse. Okay, maybe I'll write a second prompt. We got into the idea of context engineering, which is we try and shape the context, the environment that the agents should work in. And where we are now is actually something I'm exploring now, is this idea of graph engineering. So the idea being is that what we instead of presenting an agent with a single linear process, or even the plan, do, check, act process that we had in loop engineering. So the idea being is that we give the agent a goal to iterate towards. We're now looking at graph engineering. And what we are saying is that we have a number of nodes. Nodes in this case are obviously dots on a directed graph, points on a directed graph, and nodes are information producers. We then have the joins between nodes, the edges of the graph, and these are conduits of that information. So we end up with a node which may itself be a loop, or it may just be a simple linear instruction, but it produces a response. So, for example, a very simple linear process could be make sure you capitalize Jonathan Kerr's name when it comes through, or capitalize any name coming through. And so it would be given a string of text. It would say, yes, I recognize that as a name. And it would then, in my case, put a capital J, a capital C in the appropriate places. And I think that, as I say, from that very simple example, we can then say, well, actually, we want to do other things. Perhaps we want to check that this person exists on LinkedIn. So there we're starting to build a loop. We may want to enrich that data given to us in other ways. So we may say, who is Jonathan Kerr connected to on LinkedIn? And then that starts to become a more complex node, but nevertheless, it is taking an input and producing an output through the edges of the graph. So this process then, as we are designing things in graphs, needs to have as the overall context in that graph says that your actions must be compliant with the KuppingerCole acceptable usage policy in the case of our environment that we work in. So I would say this is something I'm still exploring, the idea of graph engineering for, as you say, instructing these LLMs, which, as you say, when you reduce it down to the absolute basics, are really, as you say, just clever parrots. We're trying to teach the parrots to be clever in the right way, especially when you consider the fact that we are, as you say, through Agentic work, we're giving the parrots tools. So these aren't just parrots chirping away in isolation. They're more like, parrots that we've given buttons to push, execute a Unix command, make an operation on an Active Directory or any kind of, obviously any kind of IAM structure. And this then gives rise to where does the human sit in the loop? And of course, in the case of if we were coding up an incident response graph, one of the things that is most important in an incident response scenario is that we contain the incident. And it's arguable to say that if we have, as we believe, in fact, as the news events of the last 24 hours, and today is Tuesday, the 18th of August, and we've seen a number of very aggressive cyber attacks, which certainly seem to have ramifications in a number of industries. And so when we are dealing with AI augmented attacks, our AI augmented incident response perhaps needs to say, the human in the loop comes after the fact. So this is what I did. Was it okay? And therefore, then the human response is, yes, it was okay, thus reinforcing the behavior, or no, it wasn't okay. You need to undo that and then redo in the correct pattern. Then obviously trying to unreinforce, demerit that behavior. Thank you. For those listening, my English really is my first language, but Matthias has certainly studied it far more than I have. So yeah, as you say, we weaken the impulse to it behave in that way, and we suggest a alternative preferred behavior. It's very hard to use word like behavior because here I'm checking myself that these are pieces of software. They are not necessarily endowed with intelligence. They are not necessarily endowed with any awareness. These are, again, open questions that the various research institutes are coming up with. And we're still trying to understand exactly what does theory of mind mean when it's applied to agent? What does it mean when we talk about an agent executing behaviors? What does it mean when we talk about an agent having directed goals? And because all of these things, of course, are anthropomorphic linguistic concepts, because that's where we come from. And we don't have any way of describing it other than, I'm using behaviors in the same way as I use it as applied to my dog. So when my dog this morning offered me its paw, I was like, good dog, thank you. That's reinforcing behavior, perhaps giving a little treat to say thank you, and again, encouraging that behavior. As you say, there's a debate about the level of these things' intelligence. Are they as intelligent as my dog? Are they as intelligent as an octopus? Are they as intelligent as an orca? So all of these are, we know, exhibit intelligence, but don't necessarily have the consciousness, the theory of mind that we believe is exhibited in humans. But as I say, these are open questions for researchers. Where we come back to in our roles, which is obviously offering practical insight to our clients is that it is important when you are instructing these things, and now instructing is now more complex than just, hey, do this and give me the result. It is very much now we are writing plain text software programs and then giving these to the LLM to interpret and launch appropriate agents, which have access to tools and so on and so forth. Then we need to make sure that we do not have any ambiguities, that we do not have any uncertainties, which the LLM will try and fill in from its knowledge base, which in many cases includes adversarial cybersecurity. So it's, yeah, I'd say this is a fascinating area, but I think that the thing that the CISOs can take away is that when they are writing guidance for business analysts, for perhaps software developers, anybody who is actually trying to create structures and agentic structures to operate, that we must include context that refers to organizational safety, organizational cooperation, and organizational trust. So it must not do something that damages the integrity of the organization. It must not perform an action that is outside the risk tolerance of an organization. And so all of these things are explainable concepts. You and I can discuss, what organizational tolerance means, and then we can go to our clients who may well be a telecoms organization or a bank or a manufacturing organization. And then we say, right, this is where we think your risk tolerance is. And they will go yes or no. But we will then agree what risk tolerance is for our clients. In this case, the CISO then needs to take that concept of risk tolerance, and it needs to be included as a prerequisite, as I say, an overarching factor in any graph engineering that's being implemented.
Right. To wrap this up, this is, first of all, I think the audience has already recognized and realized that these episodes will be a bit different. They are not that deterministic as others are, because there is no simple solution. The question that we started with is, how can we leverage and control and manage the interaction of different agents working together on a joint challenge, on a competing challenge, and how do we make sure that we understand what they do, and what they do is still aligned with what you said, so with business cases, with your expectations, with policies. That is where we started. We very quickly had this anthropomorphic or dogomorphic, if this is something. So we compared it with dogs, with cats, with animals, with kids, to say, okay, all of those need to learn to cooperate, and we need to understand what they're doing actually. And there are much more questions hiding in this interoperation. So let's think 3 agents collaborate with each other, but each agent does only know a slice of the challenge and the facts about that challenge. How do they exchange? How do they combine this information? No question for today. This episode is getting to its end. But these are questions that need to be solved. How do we make sure that, although they are so bright and 3 are much more brighter than only 1, how do we make them cooperate, and how do we make sure that we understand what they do? Zero trust. Don't trust them, but verify what they're doing. How do we verify? That exactly is something that you're looking into with your practice AI. And that has influences on everything that we do today, including IAM and cybersecurity. So there are lots of questions that we can follow up on in upcoming episodes. And I'm really looking forward to do that with you, Jonathan. I close down now. If you have questions, if you have comments for this episode and for the upcoming ones, please leave your comments when you're on YouTube, just in the comment section. Yes, Jonathan and I, we do read them. You will find the link to the reference research on Anthropic in the show notes, and you will find some links to the research that Jonathan and I do in these areas, how they are mapped to the topics that we as KuppingerCole Analysts cover. And final statement before I get with the final question to you, Jonathan, I want to highlight there is an event in early October. I think it's the 6th of October in Munich at the Marriott Hotel, the AIdentity and NHI Impact Day, which covers a lot of these topics mainly, and predominantly from an identity management perspective. But as we all understand, this is not the single perspective that we can apply anymore anyways. So if you join us in October in Munich for the AIdentity and NHI Impact Day, single day event, that would be great. And we are looking forward to discussing all of this and more together in person, together with you. Now, the final question. If there's one statement, one thought that you want to leave the audience with to ponder on until we meet again, Jonathan, what would be that?
I think that the significance of this topic to CISOs is substantial. And I think one of the things it points to is that if agents are highly correlated but lack coordination, redundancy does not provide the risk diversification that we would expect. So this impacts business continuity. This impacts many, many strategies that have focused on risk reduction through diversification, through duplication.
Right. So trusting multi-agent systems with security critical or governance relevant regulated business processes is a different beast. And we should keep that in mind. Thank you very much, Jonathan, for being my guest today. I'm already looking forward to the next episode. Thanks, Jonathan.